In this problem, we are given the signal xn and we are asked to determine its even part and odd part. First, let's recall the definitions. The even part of a signal is equal to 1/2 xn plus x minus n. Similarly, the odd part of a signal is equal to 1/2 xn minus x minus n. Therefore, our first step is to construct x minus n. To obtain x of minus n, we simply replace n with minus n, which corresponds to reflecting the sequence about the vertical axis. For example, the sample at n equals 0 remains unchanged and it still has a value of 3. The sample at n equals -1 moves to n equals 1 and keeps the value 2. The sample at n equals -2 moves to n equals 2 and keeps the value 1. Likewise, the sample at n equals 7 moves to n equals -7 with the same value of 1. All other samples are 0. Now that we have obtained x minus n, we can proceed to find the even and odd components. To obtain the even part, we add xn and x minus n and then multiply the result by 1/2. Let's evaluate the samples one by one. At n equals 0, we have 3 plus 3, which gives 6. Multiplying by 1/2 gives 3. At n equals 1, the sum is 2, and multiplying by 1/2 gives 1. At n equals 2, the sum is 1, giving 1/2 after multiplication by 1/2. At n equals 7, the sum is 1, which again gives 1/2. Similarly, at n equals -1, the value is 1. At n equals -2, the value is 1/2. At n equals -7, the value is 1/2. Therefore, the samples form the even part of the signal. Next, let's determine the odd parts. For the odd parts, we subtract x minus n from xn and then multiply the result by 1/2. At n equals 0, the two values are equal, so the result is 0. At n equals 1, xn is 0, while x minus n is 2. Therefore, 0 minus 2 gives -2. And multiplying by 1/2 gives -1. At n equals 2, 0 minus 1 divided by 2 gives -1/2. At n equals 7, 1 minus 0 divided by 2 gives 1 half. At n equals minus 1, 2 minus 0 divided by 2 gives 1. At n equals minus 2, 1 minus 0 divided by 2 gives 1 half. Finally, at n equals minus 7, 0 minus 1 divided by 2 gives minus 1 half. The samples form the odd part of the signal. And that's how we obtain the even and odd components of a discrete time signal. We have solved several similar examples in this series. If you found this video helpful, please consider liking the video and subscribing to the channel.